Welcome to the show, and my name is Bret. This is my channel. I'm here every week talking containers, Docker, Kubernetes, DevOps, all the CNCF projects, and we've got some more of that today on the show, so I'm excited to get into it. We're going to have some demos. We're going to talk about vCluster, something that I don't know anything about, and these guys are going to teach me all about it, and we're going to get into it. So real quick, just some of the admin stuff. If you're new and you haven't watched this before, Thursdays is when I'm live. Come join us if you're not watching this live and ask questions. That's why I have guests on the show and we do it live. So you can ask questions. We can get your feedback on what you need to know about the tools or the products or just the conversation we're having. And you can follow along. You can basically just go over to Patreon, link below. You don't have to give me any money. You just scroll down and click the follow button. That will give you probably about 1, maybe 2 emails a week. That might be the podcast coming out. That might be new open source projects I'm releasing. I'm currently working on a whole bunch of GitHub Actions stuff, so you'll probably see some of that this year about new examples and ways to do stuff in GitHub Actions for DevOps. So follow along there. If you'd like to sign up for the memberships, I have a couple of special things there, including our monthly, basically it's a DevOps hangout every month on our Discord server, DevOps Fan right there. You can go to DevOps Fan for free, join our Discord server. We're over 9,000 people now, so we're going to be celebrating getting to 10,000 here pretty soon. So we're going to do that. And then every month for the $5 high fivers group, if you want to join, it's basically like an hour or two of us just hanging out, talking about projects we're on. It's in a nice little safe space in Discord. And yeah, we just sort of have a water cooler thing going on. So check that out. Thank you so much to you patrons. You are the sponsors of this show and the podcast that comes with it. And I really appreciate you. Thank you so much. All right, well, let's get to it. On the show today, I've got a couple of pros right out of Loft Labs. We've got there in the middle, we've got Lukas, the CEO and co-founder of Loft Labs. And then on the right over there, we've got Rich. We got their Twitter handles below, so you can go follow them immediately, because I've been talking to these people on Twitter for a while now. In fact, Rich and I realized we've known each other for years on the internet. So it's always great to have fellow internet friends on the show. Welcome.
I see you managed to get out of mispronouncing Lucas's last name, so that was very slick.
Lukas Gentele. I'm going to say it the American way. And Rich Burroughs over there on the right. If I talk fast enough, then no one notices.
Yeah, that's perfect. I'm fine with anyway. Either pronunciation is fine.
Thanks for having us on, Bret. It's really good to be here.
It is, and I'm glad to have you both on. And it's we're now 2 weeks in a row with multiple guests, so this is up in my game. This is making me actually pretend to know what I'm talking about and be the show host. So thanks for being here, and thanks for dealing with all of my inconsistencies. So we're talking about vCluster today, and for those of you, if I say vServer or v anything else, I apologize. We've been joking that I've already called it the wrong name 5 times now. So vCluster is a project that is near and dear to your hearts, it sounds like. But before we get into that, let's understand your background and how you got where you're at. So Lukas, you're in the middle there, so you're first. You're co-founder of Loft Labs. Like, tell me about that. How did you get to where you're at?
Yeah, I'm definitely, I'm the CEO of the company right now, and unfortunately don't get to code as much as I would like to anymore. Someone has to actually, raise funds, hire people, and build out the business, talk to customers. But I'm an engineer at heart, and it's really hard for me to always, not dive into the pull requests that the rest of the team is opening up, and I'm always envying their life on being able to, ship features every day. I got here. I've been, I guess, on the startup journey pretty much all my life. I started, building custom websites and stuff like that when I was in high school, and all throughout college. Always had a, company going, kind of side hustle. And I was running more of a consultancy and custom software development company in Germany when, the whole Docker Kubernetes wave came up. We did a lot of things with containers, and then we built an open source project called DevSpace, originally internally for our own use. And then, that became pretty popular. We started diving more into the space, and essentially that's, when my co-founder and me, he was, essentially the first hire in my previous company. We saw an opportunity there to fix some kind of the developer experience and some areas in terms of Kubernetes multi-tenancy. And that's when we started Loft Labs.
Nice. I'm actually going to be pulling this up here just so we can. The show isn't focused on Loft Labs, but it's obviously a lot of where the inspiration for this came from for this project. So, what's the elevator pitch for Loft Labs, real quick, just so I understand what it's about?
Yeah, it's great. You pretty much already pulled it up, right? We are essentially helping you scale self-service access to Kubernetes from, really 10 to 10,000 engineers. So the idea is really when you want to have, when you're looking at Docker, a lot of engineers can essentially just, download on their local machine, run things like Docker build, Docker run. Docker is such a great developer experience, right? And then you see that migration towards Kubernetes. You see ops is really excited about Kubernetes, production workloads moving there, CI/CD pipelines moving there. And then you look at your engineering teams, and they're not quite as excited as about Kubernetes from a developer perspective than they are with Docker, just because there's so much complexity there. So when you want to enable a large number of your engineering teams to be able to work with Kubernetes, you essentially need to facilitate how do you provision Kubernetes for them, because it's not like you can spin up an individual EKS cluster for everybody. If everybody manages their own little pet Minikube cluster, that is quite, difficult, breaks often. It's kind of tough as well. Your fans are going to go crazy. Your laptop's going to be burning, right? What we allow you to do is essentially spin up these virtual clusters that run on top of a shared EKS cluster. So an engineer can literally run a single command. They have a fully fledged Kubernetes cluster, but it's a virtual cluster. So it's really cheap. We can put it to sleep when you're not using it. You can have 10 of them and switch back and forth between them. It's a really great experience in terms of self-service. And then we have DevSpace, our open source developer tool on top of that essentially facilitates that kind of workflow with Kubernetes. How do I stand up my application and its dependencies? How do I hot reload containers inside that Kubernetes cluster when I change a line of code? That's essentially the two core things that we focus on. How do you make the self-service provisioning part easy for the organization, for IT to kind of, give people access to Kubernetes? And then on the other side, how do we improve the productivity and the developer experience for engineers? That's really the core focus areas of our company.
Nice. Yeah, that's sort of a theme of Kubernetes, right? Is that it was made for ops, not for devs, but devs are having to learn it. they're now responsible for at least some part of it. Well, thanks. Rich, okay, so how did you get to Loft Labs?
So it's a long story, but I'll give you the shorter version. So I started off as a sysadmin in the mid 90s working at an internet provider, which is actually a pretty common origin story, because suddenly everybody needed sysadmins. And I was somebody who I just was messing around with Linux as a hobby. I loved it. And it turned into a job. And so spent many years working in operations for lots of different companies like WebMD and Puppet. And eventually was looking around, and I had not heard of Loft Labs at all. Lukas contacted me out of the blue. I had never heard of the company. I didn't know what to expect, and I started looking into it. And I had lots of friends in the Kubernetes community and heard many complaints about multi-tenancy problems. And having worked in operations myself, along with developers, I knew how important self-service is, right? Because I was sometimes the person that somebody else was waiting on to do a thing. And sometimes I was waiting on someone else, like the firewall team or whoever, to do a thing for me. And so I just was so impressed by the solutions they had to solve these really important problems. So I joined last April, so almost a year now.
Nice. The one of the questions in chat was where the name Loft came from.
Oh, that's a good question. I think we were just brainstorming what is a very short name that we can, that is not kind of trademarked in our field.
Yeah, we're running out.
Loft sounded very natural to us.
Yeah, I like it. It makes me think of chill. I'm in a loft. I'm just chilling. So I don't know if that's the vibe you're going for, but that's
VMware was already taken, so
yeah,
couldn't use that one. I just wanted to say hi. It's really cool seeing all these people pop in from all over the world. You've really got a really cool group of fans.
Yeah, these people. I mean, I'm very lucky, and these people are great. We got regulars. I feel like we've got the regulars in chat. We got Biker and a whole bunch of other people that have been here. Conrad is here all the time. Kamajaru, who I say his name differently every time, and even like Payam and other people. So we've got regulars, and I love it. I love people coming back asking hard questions. I think sometimes I feel like, where's that question? Like, where are we going to be here to troubleshoot your issue for the next 20 minutes? But hey, bring it. Like, that's why we're here. We're all doing this stuff for real. So let's talk about it. But vCluster. So it sounds like it was inspired out of Loft Labs and like the product you were creating. And this feels like a project for a thing I need that I didn't know I needed until I learned about it. And then I think, oh yeah, I definitely want this. So Rich, what's the origin story for vCluster?
Yeah, so I wasn't around for the very beginning of it. It already sort of existed by the time I showed up, but I can tell you the reason why it exists, which is, oh, hey, how you doing? The reason why it exists is that multi-tenancy is really tough, right, with Kubernetes. And so there's pretty much two models that people use. The one model is I've got a shared cluster for everybody, and we do namespace isolation. So an individual or a team gets their own namespace, and that's what they have access to. And the hard part about that is that there are global objects, and so teams might be developing something like a CRD, and they can't manage that. And then the other option is the cluster-based isolation, which is basically like, the Oprah thing, look under your seat and you've got a cluster. Everybody gets a cluster. And that's problematic for a lot of reasons. The big one is that it's a management headache. There's also a lot of cost associated with running all these different clusters, right? And there was a really great talk that I reference a lot. Holly Cummins from IBM did a keynote at KubeCon a few years ago about the environmental impact of all these clusters that are out there running. They're running workloads and nobody's even using them half the time, So that's sort of the problem, right? Is that this multi-tenancy is really hard. Kubernetes just wasn't really designed for it, right? And so what the virtual clusters do is they give you a way to share a cluster, but give people an experience that feels to them like they have their own dedicated cluster.
Right. Which, if you would have asked me how to do that in Kubernetes, I'd say, I don't really think that's possible. But you're just proving me yet again that I don't know what I'm talking about, and that this is something that, I mean, there's obviously a ton of potential for uses for this, but one of the challenges is, has always been, I think, for Kubernetes is it's one thing, it's hard to set up one cluster. It becomes much harder to set up 20. And because the assumption is that none of those are going to live forever, and then you're going to be replacing them or constantly upgrading them all, and multiple times a year if you're a good person, and you're paying attention to all the security vulnerabilities that come out about this stuff. But like, we definitely are, I feel like, still in the middle of figuring out how do we manage all this complexity in a way that's sustainable for small teams? Because I don't know anyone who's got spare time. I keep trying to find engineers that are like, yeah, I could really use another 10 hours of work in my week. Like, could you give me something? Oh, great. I'm now the Kubernetes admin. Great. I just lost half of my free time. So, so let's get into it. Like, what use cases are you seeing this used for? Or maybe even a better question,
I just want to mention one thing. Sorry, I just want to mention one thing real quick, Brett, that I should have, is that I just want to point out that this is open source, right? So, these virtual clusters were initially built into our commercial product, but then I want to say it was about 9 months ago, we open sourced it. And so the project is called vCluster. It's on GitHub. You can use it for free. And we've had a lot of interest from people. People have been really excited about this because it really is a different way, to kind of approach how you share clusters with your engineers.
Yeah. Yeah. So is this a CNCF project yet? I'm trying to remember.
Not yet, but I think we're in a good path to actually putting it in CNCF. We haven't quite made that step yet because vCluster is not even a year old at this point. I
Yeah.
think when we launched it, we just launched it last year. So we've gotten a ton of feedback. We see a lot of people, even, we just shipped the plugin system for it as well. And people, take that away and start writing extensions for it. It's pretty crazy. So we're realizing the potential for vCluster. And I think for us, the goal is, because again, like vCluster is Apache 2 license. It's kind of designed to be put in CNCF.
Right.
And for us, it's just important to kind of see, okay, we have something that is actually stable and works for a lot of companies before we make that step. But yeah, we'll definitely, I can probably spoil that we're going to do that sometime this year.
I was gonna say, yeah, you only get that that CNCF blog announcement about a project going sandbox once, so you might as well be ready as you can for that. So, well, good luck. And I assumed that it was on either that path or already there, because it does seem like a very natural fit to the CNCF community. So, I think, do we have demos? I think we have demos. So for those of you watching in chat, throw your questions in now, because we're gonna get into the details of the product. I'm sure you'll have some questions on the way, but get those questions in now, and we can get to them along the way while we're working through some demos.
Sure.
Let's see. I've already got multiple questions for you, but I'm gonna wait till after the first demo.
No, we can take a question if you want to show one.
So we're. How does vCluster compare to Kubernetes hierarchical namespaces?
Oh, that's actually an awesome question. How someone's diving deep into other options as well. Yeah, so what hierarchical? I mean, everybody kind of knows what namespaces are in Kubernetes, right? It's kind of like you're prefixing names in Kubernetes effectively, right? To be able to call a deployment database and then call another deployment database. You put them in two different namespaces, and suddenly it's not a naming conflict anymore, right? What hierarchical namespaces allows you to do is you create a base namespace, and then you inherit certain things from that namespace. So let's say you want to share Kubernetes cluster, and you create a network policy in one namespace. You can now allow people to spin up their own namespace that inherits, these kind of isolation resources from that central namespace. The limitation of that, though, is you still cannot use any cluster-wide objects, right? You're restricted to your namespace. Mm-hmm. That means you can only create namespace objects. That means you can create deployments and services and pods, right? But you can't add a CRD to the cluster.
Right.
You can't change the Kubernetes version. You can't add a storage class, right? Because to do any of those things, you need to be a cluster admin. And vCluster actually gives you more than just a namespace. It gives you a fully fledged cluster that runs inside of a namespace.
That's a fantastic explanation. And I'm sitting here thinking, I'm very curious about that too, Martin. Yeah, that's a great point, because a lot of it, it's not often that you realize all of the cluster level stuff you need to do until you don't have cluster admin, and you feel kind of handicapped. You're like, I don't know how I can get anything done. I want to install my cool CRD or my new controller that my favorite new tool or whatever. Yeah, so that does get very problematic very fast.
Yeah, it's not just CRDs and those kind of things. It's also things, let's say your engineering team starts to architect things in a way that, you have a microservice that has a dependent microservice that is supposed to be in a different namespace, right? If you have hierarchical namespaces, or for that matter, any kind of isolated namespace, and you have a network policy in place that only allows you to connect with pods inside your namespace, what are you going to do now when you decide to actually split up an application across namespaces, right? That may be a valid choice, and then you need to make exceptions to your network policies. Who's going to maintain these exceptions? There are a whole variety of these problems, and that's when we saw them, because originally what we did in the commercial product was essentially just self-service for namespaces, right? Kind of what hierarchical namespaces does, we did in our commercial product, self-service for isolated namespaces. And then our customers were telling us, oh, now my engineers need CRDs, and my engineers want to communicate across namespace. My engineers want to do this, right? And we were thinking like, dang, right? Now we have to tell them, make all these exceptions, and then here's how you manage these exceptions, right? And that just gets out of hand. So we were thinking about, isn't there a smarter way? And then we built Virtual Cluster originally in the commercial product. And then, from there, we just saw such a great potential in the underlying technology of spinning up these virtual clusters that we decided, hey, we got to open source that and open it up to other folks and see what they're going to do with it. And that's how vCluster essentially got started.
Yeah. Maybe a question for later in the demo, but Niels asked, how do you deal with system updates and K8's upgrades gracefully with vCluster? Now, I don't know if that question is about the host cluster or the vCluster inside of it, but I guess assume both.
Yeah, I think for the host cluster, in the end, like vCluster itself runs as a pod inside your cluster, right? So if you want to upgrade the host cluster, you always have to think about what happens to workloads, right? The same consideration applies for vCluster. And then I think, if you're having a newer host version, that's usually not a problem because, essentially your Kubernetes is pretty downward compatible. So that shouldn't be a huge issue. We're also just relying on a subset of resources to be the same between the host cluster and the virtual cluster. One of them is obviously pod, right? The pod spec needs to be the same between the two, or kind of downward compatible at least. And I don't think pod spec has changed so much, at least in a breaking way, right? I haven't seen anything recently that would change the pod spec, and I don't think anyone in the Kubernetes community would want to introduce a breaking change.
They're really trying hard. They're really trying hard to avoid breaking changes.
Yeah, exactly. And I think for upgrading the virtual cluster, that's an interesting question. It's literally just changing out an image tag, pretty much. It depends a little bit on what distro you're running, because the funny thing about vCluster is also vCluster itself is a certified, Kubernetes distribution. That means we pass the CNCF compliance test, just like EKS and GKE and K3S. That means you kind of, it works the same way as a regular Kubernetes cluster. But the funny thing is, you can actually choose which distro it runs, which API server it runs. So you can run a vCluster based on K3S, or based on Kubernetes upstream, or based on EKS. The AWS team recently contributed that. With Mirantis, we added K0S recently. So it's kind of funny. You can have an EKS cluster that, in the end runs K3S inside a namespace, and a different namespace there's K0S, right? There's different options. And then regarding upgrades, you have to look at that specific distro that you're actually running.
Yeah, that's great.
Yeah. Use cases also come into it, right? Because I think that a lot of the use cases that people are going to use vCluster for are going to be more ephemeral things, like a dev environment, or spinning up systems under test in a CI/CD pipeline. And so they probably don't even care about like upgrading the cluster, right? They're just going to spin up new ones with the new version.
Nice. That's something that I never actually thought about, was actually running other, like everyone's probably heard of Kind, the Kubernetes and Docker, variant or distribution. And I always use that as an example of an easy way to spin up a cluster when you need it for testing or local machine. But it's its own distro, so it's got its own nuances that aren't always obvious when you start using it. And there's tons of people that love keys, that love K3S, like they're K3S all the way, all day long, right? And for those people, they want to stick with their distro, and so it's actually, I think that's a really interesting idea, to allow you to deploy other distros, not necessarily only your own distro, I guess, is the vCluster. So vCluster can run vCluster, but vCluster can also run K3S, or
it needs an API server.
Okay.
Yeah.
We don't. Yeah, it needs an API server. That's what sits inside the namespace. And we started off with K3S, and this feedback came from people in the community. People came to us, and there was somebody who was a big fan of K0S, and they were like, "Can you add that?" And so we did, and that's been one of the great things about this project, is that people have been really excited about it, and we've gotten a lot of great feedback, and a lot of it has kind of helped the project grow.
Yeah. All right. So a few more questions, and then we're going to get into it. Martin asked, what about running production workloads on vCluster? Do you see this happening?
Oh, that's a very interesting question. So in the beginning, again, we started out with these ephemeral environments, and focusing on dev environments. CI/CD, it's really great to be able to spin up in 3 seconds, fully fledged cluster, right, instead of having to wait 20 minutes for EKS to start in your pipeline. That's not even, I don't think anyone does that, because it takes so long, right? And then obviously the next step is kind of looking into, hey, can we also use that in production somehow, right? And we have seen customers put it in production. I don't have any example that I'm publicly allowed to speak about, because obviously people are kind of scared about talking about this when it's not, when they're just starting out with it.
Sure.
They need to see if it actually works at scale. But we do have a couple of pretty large customers on the commercial side of things that are now exploring vCluster in production. And that's super exciting to see, because vCluster is very lightweight and it encapsulates everything application specific inside these vClusters, which is something that you really value in production. Because when you're thinking about it, let's say you have a multi-tenant product, right? And you can either host different customers in different Kubernetes clusters, which is really scattered, and you have to have like all this common stack, monitoring, logging, managing these clusters. Everything's replicated, a lot of work. So a couple of customers thought about, hey, if we put them in vClusters, certain things can be shared, like that monitoring and logging for the actual pods, for the actual workloads would be shared. But then our own CRDs that we're shipping to host these multi-tenant environments, they would be isolated. So we can upgrade customers individually, right? Because like if you upgrade a CRD, it's cluster-wide. It's like
Right.
all or nothing, right?
Right.
Are you really going to run multiple customers in the same Kubernetes cluster? It's really difficult today. vCluster really makes that possible now. And another thing is, when you're actually hosting, when you're hitting, in a way, almost like the scalability limits of Kubernetes, there's a lot of requests to etcd into your API server. But now with vCluster, everybody gets their own, every part of your system gets their own API server. So you can essentially shard your cluster in a way, and your underlying host cluster has much less workload, and it can be much dumber, right?
Right.
Because that Kubernetes version, these flags and upgrading can be done by system, by microservice, by component, however you kind of divide up your system. It doesn't have to be that global massive operation in a 5,000 node cluster anymore, right? That's really, really interesting in production in terms of reducing, kind of management effort for, for these production workloads, and, increase resilience.
That's actually a really interesting. While you're talking about it, I'm realizing that I actually already know people that have a need like this. They don't know that they need it yet, but once a company gets big enough and like central IT starts to take over or run the Kubernetes clusters, but developers want API access, they want to roll their own CRDs. One team likes Flux, one likes Argo. There's and the team, as the teams invest in their own Kubernetes more, they're less tolerant of sort of an IT overlord, telling them that, no, we're running this version of Argo. That's all we run in the cluster. This is how we set it up. And everybody has to obey by that, right? And they don't want to run 1,000 different versions of Kubernetes cluster design. And I don't blame them. Like I am one of those IT cartel people that gets in the way of progress for developers. So I understand that and sympathize, because I kind of sit on both sides of that fence. So this is interesting, because this would sort of give the guidelines for the IT team to still, like you said, have a simple, super simple setup that only needs, it's basically there to just deploy other clusters and run the centralized logging and monitoring that, in a lot of ways is kind of boring for developers. They just want it to magically work, right? Which is why I'm a fan of the SaaS in that
No
part.
more excuses for IT.
Yeah, that's right. That's right. And then you give the developer sort of freedom of choice, and you say, hey, if you want to run Argo, it's up to you. It's going to only be scoped to your namespace, so you can't hurt other people, and give them sort of their own little sandbox that they can just, to their own detriment, in certain ways, sort of set up their own stuff and run
That's
with it.
actually Go ahead, Rich.
Oh, I was just going to say, I've always been really interested by that Netflix model, if you talk to their SREs there, they have a central set of services that they provide, and so, if you don't want to figure out how to deploy your app, they have a way for you to do that, but they have that freedom and responsibility thing, right? So like if you can think of a better way to do it than what they're offering you, or one that fits your use case better, you can do that, but you're also on the hook for it working, and I think that's really interesting. I think that one of the really big values for us is just enabling developers, right? And that's why the self-service thing is such a big point for us, because these things affect people's velocity, but but they also affect people's happiness. If you're stuck in one of those situations like you described, where the IT overlords are telling you to do something that you don't really want to do, that like hurts, right?
Right.
Like that can really bring you down. And I think that's something that people don't talk about enough, is like what is the cost productivity wise of somebody like not being happy doing their job,
Yeah. Well, and for, we both got the nice long beards. We've been around this block a while. Like, for the last 25 years, all I've been doing is trying to get out of the way of developers wanting to get their stuff done, but helping them manage it in a way that isn't going to get everyone in trouble and put data at risk, right? So, like, there's that constant tension. That's why the DevOps spoke to so much, that word and the idea spoke so much to us all, was that, yeah, let's not throw things over the fence and be adversarial. Let's work together for this. And Kubernetes is like, I have teams now where they've got their own data centers. They're not cloud. They're not doing everything in the cloud. For those of you out there that think that everything's in the cloud, it's totally not. There's tons of data centers everywhere. And their challenge is they want to give the developers the way to scale up and down Kubernetes and like roll their own Kubernetes whenever they want. But when they're doing that now means they have to deal with the VMwares and they have to deal with provisioning VMs and provisioning physical servers and all that. And they I think they're all really searching for this model of, how can I provision a bunch of things and then let the developers do what they want with Kubernetes without the risk of them basically having complete root VM SSH access, right, to all the machines and letting them do whatever they want there. And I love this idea of the sandbox. So we've got tons more questions, but I really want to get to demos. Maybe while we're starting out the demo, I can just throw you some curveballs or something.
Yeah, do you want me to share the screen? And
yeah, let's do it.
I have a couple of slides we can go over to kind of understand the concept a little better, and then we'll dive into like a live demo, to really see how it works when we're spinning it up in the terminal. So first of all, I think we already got that with hierarchical namespaces. Namespaces are not virtual clusters, not the same thing. I gave a talk at KubeCon North America in LA last year, and I used a slide deck to essentially emphasize that part, because the official Kubernetes docs was actually listing that namespaces are virtual clusters. And when I read that sentence in kind of preparation for the talk, I'm like, no, right? We can't say that. Namespaces are not clusters, right? And it's important to understand namespaces are essentially just scopes for names. Right, that's really how I see it. Versus, and that's actually that was further down somewhere in the Kubernetes documentation, but I feel like that should have been the first sentence, right? But then there are a lot of cluster-wide objects, and there's actually a way for kubectl to tell you which resources are cluster-wide and which one are namespaced. You can essentially run these kubectl commands with the namespace true or false flag, and then Kubernetes will give you a list of resources, right? Yeah, so that was from the talk. We actually saw that statement, right? And we even got that fixed after KubeCon. I told people, hey, go ahead, fix docs, right? If you go to the docs now, it has a much better version of describing what a namespace is. What we're essentially doing with virtual cluster is to run a control plane inside another Kubernetes cluster. So when you take a regular Kubernetes cluster, right, we have an API server, and then we have a data store like etcd, right? It's a standard backend for Kubernetes. And then we have a controller manager, which controls our replica sets. And then we have a scheduler, which essentially schedules our pods to the different nodes in our cluster. And then we have the workloads, right, which are separate from our control plane. And we typically launch namespaces to essentially run, pods in them. And typically we don't have just one namespace, we have multiple of them. That's how a regular Kubernetes cluster looks like. What we do with virtual cluster is now we think about, okay, what if we don't talk to that Kubernetes API server down here and run kubectl commands against it? What if we instead spin up a control plane that runs as a pod inside of a namespace? That means we have an API server that runs as a pod inside of a namespace inside of Kubernetes. And now we can talk to that API server, right? That's this core idea. If you understand that, you pretty much know what a virtual cluster is, right? It's a little bit more complicated in the details when you're actually thinking about, how does this control plane look like? So in the easiest case, vcluster is just has a host namespace. It can be any namespace in your cluster that you're creating for it, and then you're deploying a stateful set, and you're deploying a service, because that's the service you're actually talking to with your kubectl commands pointing at that service. And then the stateful set you're spinning up essentially has the API server and the controller manager. And that's where you pick, K3s, K0s, upstream Kubernetes, EKS, right? Can be any of these distros. But as you may see, there is not a scheduler there, right? We're not using the scheduler of K3s or the scheduler of EKS, right? We're only using the API server and the controller manager, and we're hooking it up to a data store. So that means when I'm writing something to my K3s API server, it writes it into a separate SQLite in the easiest case, which is just mounted as a volume to that pod. Or it could be a MySQL database, or you could deploy a fully fledged etcd in separate pods, right? There are multiple ways to do that. But the big difference to a regular cluster is we don't have a scheduler. Instead, we have a so-called syncer. And the syncer is really what makes the virtual cluster virtual and what makes vcluster its own distro, because the syncer, instead of connecting to the nodes directly and being able to manage these nodes and being able to like a full cluster, right? Instead of that, it essentially just synchronizes your workloads down to the underlying host namespace. That means when I create a pod inside my virtual cluster, what it does, it creates an entry in my virtual clusters data store here. So we have an entry for this pod in our virtual etcd or SQLite, and then the syncer sees that and synchronizes the pod down to the host namespace. So it talks to this API server to actually create a pod. But all the higher level objects, the things that are creating pods, deployments, stateful sets, all these kind of things, they stay entirely virtual inside this data store. They will not be synchronized down. That's in a nutshell what a virtual cluster is about. So let's take a look at how this actually looks when we talk to this virtual API server. Unless there are any questions to it. I know this can be a bit overwhelming sometimes.
Yeah. So, well, first off, thanks so much, Niels. We got a super sticker, so I appreciate you. Thank you so much for helping us out on this show. I unfortunately can't put the little Giphy in the. I don't have the ability to do that. So it's funny because the text describes it. It's a hippo character with stars growing in his eyes, pumping his arms in the air with the word hype pulsating above him. It's kind of a weird way of putting a Giphy on screen. But hey, I appreciate you. Thanks so much, Niels. For those that didn't see the message, we've got a bunch of questions coming in, and we will absolutely get to those. I think we should get a little bit more into the demo, and then we'll probably have some more questions we can sort of break for that. What do you think?
Yeah, sure. Sounds great.
I saw the question about Ian Coldwater's talk. I haven't seen that talk, but what they described does sound similar. I know Ian. I'm pretty sure Ian has seen vCluster as well at some point. They're a super rad person.
Yeah, and they're probably gonna break it and show it off at some point. Yes, good people. All right, what's up? What's next? Creating namespaces.
Let's take a look at how this actually looks, when we open up the CLI and run a little demo here. I'm currently connected. Let me actually confirm that and list the Kubernetes namespaces here. Yes, last night I spun up an EKS cluster, and we can essentially just create a namespace in here. Create namespace. Let's just call that, I think we can just call it NS1. So that will give us a namespace in our regular EKS cluster, right? That's the part that IT would do for you at this point, right? Or some kind of automated pipeline, right? And then the question is, do you want to hand out that namespace? Do you want to put a whole bunch of isolation things in here? Or do we just spin up a vCluster and hand out that vCluster to our users? So what we can essentially do now, inside that namespace, we can create vCluster, vCluster create, and we call it, VC1, virtual cluster 1, and we say it should be started in the namespace NS1, similar to, kubectl namespace flag. And that's going to spin us up a virtual cluster. You can see the commands that it's running under the hood. It's running Helm to essentially deploy the vCluster Helm chart. We can take a look at what is running in here. It's pretty much spinning up this control plane that I was just describing, right? So we have a stateful set that actually runs 2 containers. Going back to the slides, right? So that is this container here running our distro that can be K3s or EKS or whatever you're choosing. And that container is like the API server and controller manager. And then we have the syncer as a separate pod, right? And then if we now have that virtual cluster running, let's wait till our pod has started, and you can already see core DNS has been started for some reason here, and it looks kind of different because it has like kube system in here and stuff like that, right? But let's take a look first at what the perspective looks like from inside the vCluster, because so far we've been using the kube context to talk to the EKS, API
Right.
server. But we actually want to talk to the vCluster API server. And we could just run kubectl port forward now to port forward, to that virtual cluster service. But it's even easier. We can just run vCluster connect and say it's running in namespace ns1. It's called vc1. And then I can also say, hey, I want to open a bash, or I can, run any kind of command here with that context. So let's go ahead and do that. Let's say we want to open bash. And then we end up on our local machine it's opening up bash, and what it also does is it's creating me a kube context here inside that shell that it now connects me to the virtual cluster's API server. So when I'm inside here and I run kubectl get pods, now let's actually run kubectl get namespaces first. We now are talking to the virtual cluster's API server, and we see, kube system, default namespace, all of them have been created 100 seconds ago when we spun up this virtual cluster. So we're not talking to the EKS cluster anymore. We can now, run kubectl create namespace test. And if we, split the terminal, and now we're in our regular, regular shell here without actually having the only thing that actually this bash does is it sets the kubeconfig environment variable and points it to a temporary file that has a kubeconfig that points to that service, right? You could also do these things manually, start port forwarding, create a kubeconfig, right? Set that environment variable. vCluster connect is really just a kind of shortcut. If we run kubectl get namespaces here, we'll see that this test namespace we have created does not exist in the underlying EKS cluster, right? It's only virtual. It only exists in that data store that we have attached to our virtual cluster's API server. And then what we can do here inside our virtual cluster, creating namespace is already pretty powerful, right? In the underlying cluster, I don't have permission to do anything. Right? I can't create namespaces. I can't create deployments, right? But I can do anything inside this virtual cluster. I can even take a look at kubectl get pods inside, kube system, right? See what's running in there. And we're actually seeing there's core DNS running in here inside the kube system namespace, right? And that's what we saw earlier. This pod has actually been launched inside the kube system namespace, and the pod gets synced to the underlying cluster, but not that namespace, and not the stateful set of deployment that has created this pod. So if we kind of do that by example, we could essentially, let's go ahead and do that. We could run,
real quick,
kubectl.
Saying that another way, I'm just making sure I'm following. So from let's imagine that the real EKS cluster, the IT is managing that, and so from their point of view, they're seeing everything you're doing as pods in a single namespace. But when you're talking to this internal API of vCluster, that's where you're seeing, it's the kube system namespace, and it all looks normal to you. But it's not. So it's not like we're hiding stuff from IT, right? Like IT still sees all the workloads. It just sees a couple extra that happen to be the etcd or the SQLite or whatever, as well as your main API and controllers, right? And the sync controller or whatever it's called. Yeah.
IT can obviously, they have the permission to port forward to your Kubernetes, your virtual clusters API server, so they can see the inside world of your virtual cluster.
Sure.
But in the underlying cluster, they're only seeing pods. When you're creating, when you're adding CRDs, you're creating namespaces, you're creating deployments, they will not see that in their underlying host cluster. In their EKS cluster, they only see pods of that virtual cluster.
Yeah, so if they were watching like an event log of the main EKS cluster, then really it sounds like they're just going to be seeing pod scheduled, rather than, all the other things that you're actually doing in the sub. I'm going to call it a subcluster. I don't even know if there's a right if you have that term. I'm making that up as I go along. Sorry, you were in the middle of something. I don't know if I broke your train of thought.
Yeah, that's pretty much how it works. What we can do now is just create like a demo, demo deployment, right? Let's just do it pretty dirty. Create deployment. Let's call it Nginx deploy. Inside the namespace test that we just created, and it has the image. I know usually you want to do this declarative via YAML and stuff like that, right? Just for the purpose of this demo, let's spin up
That's right.
an Nginx deployment here. So that got us a deployment.
I prefer to YOLO stuff anyway. Like,
can we do some edits and patches?
That's the kind of developer freedom that we want to give them, right?
That's right. Can somebody go edit their selectors real quick? And nice.
So let's take a look. So if we want to, inside that namespace test here, we now see our deployment. We see one of one pods is ready, right? And we can see, here are our pods, right? It looks all totally normal, right?
Yeah.
But it's all virtual, right? Because when I'm going to the underlying cluster again, I can now run kubectl deployment inside our namespace NS1, right? And we see there are no deployments in here, right? That deployment doesn't exist. But what we see is pod that actually, let me make this a little bigger. We see there is this Nginx deploy pod, right? So the actual pod, and you can kind of see it's the same name, right? 8588 and so on, right? It's the same name up here, but it has this suffix here where we're actually adding the namespace name, because otherwise you would have conflicting pods, right? Let's say you have two pods with the exact same name in two virtual namespaces. We're mapping it down to a single namespace in the underlying EKS cluster. That wouldn't work. So we're adding this one. And then because you can also have multiple virtual clusters inside the same namespace, we're also adding the name of the virtual cluster, right?
Right.
And this is kind of the view of the underlying cluster.
So the virtual cluster name, so when you're creating your virtual cluster, you have that VC1 name, and that's one of the ways it prevents the overlap. I mean, so just to be clear, before you ran that first vcluster command, there was nothing in this EKS cluster that was vcluster related, right? Like it's not like there's a controller running vcluster at the cluster level of EKS. So you could technically do, not that I'm not advocating for this, people, but technically you don't need the cluster admin's permission to run vcluster in your namespace if you've been given namespace control.
Exactly.
So the sync service makes way more sense to me now.
Boosts a lot of the vcluster adoption, right? Because if you're an engineer, and look, if you're an engineer listening right now, right, IT is not giving you the CRDs you want, right? Literally, go download that CLI, right?
Now you have vCluster.
This is like turning from a DevOps stream into a shadow IT stream.
Well, maybe that's the way you get famous, is you're the shadow IT, the shadow cluster. Maybe that was a better name.
We should have called it like that. Yeah.
So, I mean, the reality is that at the end of the day,
you need the permission to create a stateful set and a service, right?
Yeah.
That's what you need in your host cluster. And when you have that permission, you can create a vCluster. And inside that vCluster, wow, your cluster admin now, congrats.
Yeah. Well, and obviously, like, people were talking about production here. So, the things that go off in my head are like, okay, my EKS cluster maybe has 3 etcd nodes and multiple redundant APIs or schedulers or whatever. Like, I've got all that redundancy built in, multi-node and all that. But in this case, a couple of things that I'm thinking out of the box is, like, one, your API didn't, so your internal, your vCluster API isn't exposed outside of the physical cluster. So it's sort of a nested access problem a little bit there, right? Is that something that you can do out of the box where it just says, oh, I'm going to use a service so that my vCluster API is also accessible outside the cluster? Is that a thing?
Yeah, that was probably feature request number one after we launched that, because
Make it super easy.
Yeah, I guess, I mean, so the problem you're seeing here is, an engineer. So in a lot of cases, IT may not even want to give you a namespace, right?
Right.
They may want to give you separate EKS clusters at this point, because that's what they kind of know how to do, right? They spin it up via Terraform. There's ways to authenticate with AWS, right? If you are talking about sharing clusters now, that's a lot more things to set up, right? You need to have network policies, resource quotas, all these things to restrict these namespaces.
Right.
Creating a virtual cluster, and then, if you want to give it to the engineer, they somehow need to be able to do port forwarding in this case, right? So they still need to have access to the underlying EKS cluster to start the port forwarding. Obviously, that's a little annoying. So what you can essentially do is you can create an ingress which points at that service, right? And then you can authenticate that ingress with the regular methods that you have, Nginx ingress controller, stuff like that. Our product adds a feature for that as well on the commercial side of things. And that way you can spin up these virtual clusters and people can get a kube context to directly, talk to the virtual cluster without having to start port forwarding first and, setting up their kube config locally.
Right.
That's even easier, of course.
Yeah, we've already got enough levels of proxies and emulation and translation, all this stuff. So it sometimes when we get to these levels where it's like I'm running on a virtual machine with a virtual cluster inside that cluster, how many ingress rules and proxies do I need for one website to be available on the internet? So this actually is really cool.
Which actually did something funny on that end, right? Like you did the nested virtual cluster, right? Virtual cluster and virtual cluster. I remember that was one of the first things that Rich tried when he joined the company.
Yeah, there's a video on YouTube if you search for vCluster Inception, where I set up a virtual cluster like this one, and then I create another virtual cluster inside of that one.
So in case because this is real, I know of organizations where they have the main IT that runs the EKS clusters. Then the dev team has like that DevOps person, right, who needs to hand out one cluster for each dev so that they can have their own little play area, and they manage it. So now you've got a vCluster and a vCluster inside of a real cluster. I hate to say real cluster as if it's not real, but whatever. The prime cluster. All right, let's see what some questions that we can find that are related to this. Biker, I'm sorry, I don't think we're going to be able to get all your questions in from the very beginning of you were so patient. He asked about antivirus in a container, and I said, nope. I would run antivirus in a container, but not in every container. Run it in one container. If it needs to access the file system, you can totally do that on the host. Like all these are just really files on the host. That's a quick answer. All right. Thank you all so much for these questions. Oh my goodness. All right, we got the prod cluster one. Do workloads persist when you restart or upgrade the vCluster?
Oh yeah. So there's two ways to do this. Essentially, we spun it up via the CLI right now, but if you're actually going through, you can go through the documentation and deploying a vCluster. We saw that earlier. You can basically just run, Helm install yourself, right, to deploy the Helm chart, or you can literally just run kubectl apply and create that stateful set. And of course, it's easier with the CLI. But the default value that we're setting in our Helm value is to mount a persistent volume to host in K3S's case, we use a SQLite database to host your, kind of like your etcd replacement. And if that's in a persistent volume, that's going to, even if the vCluster gets rescheduled, the pod of the vCluster dies, it essentially mounts that same volume again, and all your data is still there. But you can also disable that, and that makes it truly ephemeral. And that means when you're purging the virtual cluster, all the data is gone when you're spinning when it restarts, right? It kind of depends a little bit on your use case. If you want to use it for CI/CD and it's like a one-off thing, run my integration tests for 10 minutes, right? You may not even need that persistence. But in most cases, we see people just, let the persistence be enabled, which is our default value, and then you can restart the pod, purge it, right? The stateful set will create a new pod, and all your data will still be there.
Nice. All right. How does persistence work specifically on storage?
Yeah, that's a good question. So obviously, we're translating pods, right, from the vCluster. We're copying pods, right, from the vCluster to the underlying cluster. And there's lots of options on how to configure that. In terms of storage, what you would typically do is you have storage classes in Kubernetes. When your persistent volume claims, they either use the default storage class or they specifically specify a storage class. In your vCluster, you could have so by default, you're just seeing all the storage classes of your underlying cluster, right? So you can essentially, use the storage classes of your underlying cluster. If you don't specify one, it would use the default one. So if I create, let's say I create a deployment in that, or I create a stateful set, and that one creates a pod deployment with a persistent volume claim template. That would create a persistent volume claim, and we see that it is required for that pod to start up. So we would also create that persistent volume claim with the syncer, right? So the syncer always checks what does this pod require in the underlying cluster and would create these resources as well or copy them. The same counts for, like, let's say I mount a secret in my pod, right? Obviously, I need that secret in the underlying cluster now to be able to mount it, right? So the syncer would also sync that specific secret. But it wouldn't sync all the secrets and everything. It essentially only syncs these things that are required to start a pod.
Nice. Well, we answered this one, I think. Can vCluster run vCluster?
Yes, definitely.
Yeah, we're doing that all the time. I do that a lot for demos as well.
Yeah. I'm not even thinking about this. Is there a resource name size limit? Because if you're running a vCluster inside a vCluster inside a vCluster, eventually your name is like...
you're going to hit a limit.
Yeah.
Yeah.
I'm wondering if a 255 natural limitation on... Anyway, never tried it, but yeah. So someone let us know. Someone run 10 vClusters nested all the way down. By the way, every vCluster you create, time goes 1/10 the speed, and then... No, I'm sorry. That's the movie Inception. I'm getting confused. Does vCluster create...
Yeah, the funny thing is,
go ahead.
It's not having a performance hit for the actual pods, right? Because the pods would be, it's like, let's say you have two vClusters, right? VC1 and then VC2 inside of it, right? If you create a pod now in VC2, that would be synced to VC1, that would be synced to the host cluster, but then the actual pod has no performance hit, right?
Right.
You have just this additional hop in terms of sync, but that's like, the control loop with Kubernetes is asynchronous anyway. So if that just takes, like, instead of 100 milliseconds, 200 milliseconds,
right.
You won't even notice that.
Yeah, that's a good point too, because this isn't like nested virtualization. This isn't true hardware virtualization where we're at the point of, like, the kernels have to do special things for this. This is just regular apps. That's why I was saying earlier, like an IT pro running the physical infrastructure will just see these as regular pods. They're all going to be able to do a PS from the command line at root and be able to see all the apps still running. It's not hiding or obscuring anything really. And that to me is all good stuff. Does vCluster create virtual nodes, and does a vCluster share the same nodes as its host cluster?
Oh, that's
These
an
are really,
awesome
really
question.
good questions.
Yeah, I love those questions. By the way, we have a big architecture section here in the documentation. So if you want to know how storage works in details or nodes work in details, you want to get a list of when are resources synced and what are the conditions for them being synced, right? It's all documented here. In the case of nodes, that's a very, very interesting point, because we essentially, so you have to understand the syncer syncs in both directions, right? So when we sync a pod down, that pod is being scheduled now by the regular cluster scheduler to some node, right? But then it could have like a image pull error, an image pull back off, or any kind of scheduling error, or, like a lot of things can go wrong, right?
Right.
So what we also do is we synchronize the status up, right? And part of the status is on which node is this pod running, right?
Nice.
And the default option in vCluster is we show you inside the vCluster only those nodes that your pods are actually running on. So let's say your IT could configure. So let's say you tell vCluster, you can tell vCluster certain things. You can tell it show the user inside the vCluster all the nodes, right? You could do a label selector with a node selector, for vCluster, and then the syncer would automatically attach a node selector to your pods during the sync process. That means you can restrict users to certain nodes or node groups, right? Without them even knowing that. They don't even have to configure that when they're creating their deployment. It would happen automatically as part of the syncer process. And another interesting thing is there are also ways to add fake nodes, right? You can technically, so what we actually do by default is, yes, we sync the nodes, but only the nodes that your pods end on. And because we want to obfuscate certain things, we copy the nodes, but we rename them. We make certain adjustments to their spec, right? So you're essentially seeing fake nodes to start with. But you can also tell vCluster, hey, show the people the real node specification, show them the real name. There are config options for all of this. If you go here, right, there's a lot of these YAML options that you can essentially tweak in our Helm chart. And a lot of documentation, right? Like use real nodes with a label selector, sync all real nodes, use fake nodes, right? There's a lot of ways on how you can tweak that behavior.
So, okay, let me make sure I understand this. So the default behavior is that I will, inside the vCluster, I will see the nodes that, the physical nodes of the real cluster, I'm going to call it prime cluster, the prime cluster that are running all of my workloads. And so I won't, if there's a 30 node cluster that I'm running vCluster in, and it just so happens that I'm running 2 pods and they're running on different nodes, I'll see 2 nodes in the vCluster, right?
Correct.
Now,
yes.
the fake nodes, is that so that I can, if I maybe only have like access to 1 node on the cluster, or my prime cluster is really only 1 node, that inside vCluster I can simulate multi-node setups essentially? Is that so that it's running a kubelet or something? Does it actually run kubelet?
There's 2. No, it doesn't.
Okay, yeah, because it's syncing to the
Yeah, essentially, there's 2 things that you can do in terms of faking things. One is that we just rename nodes from the underlying cluster. That means we obfuscate a little bit that node, right? It's still like one-on-one mapping, but you don't see the actual node details. You don't see, oh, this is an EKS with this version. You don't see any of this information because we fake it all, right? And then the other part could be that you're actually adding fake nodes that don't even exist and map them. Look, you could add like 3 fake nodes and map them to the same real physical node, right?
Okay.
Like your actual underlying scheduler would schedule it all on a single node, right? But you feel like you have 3 nodes in your cluster. Yeah. That is something that is a little bit harder to do. It's more of a manual process. The other thing with the obfuscating via names is basically set like a true false flag, right? The syncer can do that by default already.
Right. Okay. I think I'm maintaining an understanding of what's happening here. It's my brain trying to start to hurt. Biker asked a pretty related question. Are the expensive components, the nodes, this is an IT person, the mindset of, I got to run these nodes and justify the cost for them. Are they shared across the vClusters? If so, are there quotas or limits on memory CPU and a given vCluster can use?
Yes, absolutely. So the cool thing about this is when you're thinking about it, the way you would typically limit things is with resource quotas in Kubernetes, right? Resource quotas in Kubernetes have the problem that they're namespaced. They're unfortunately a namespaced resource, right? So if you want to give a developer 4 namespaces, you can only set a limit in each namespace rather than having 1 limit for that particular developer, which is what as IT, you basically want to give a limit per team or limit per developer, right? Rather than a limit per namespace, because how people are splitting stuff up on a logical layer is like really, you couldn't care less, right? But you really care about if someone's using 20 gigabytes or 30 gigabytes total, right?
Right.
So what you would do is you would create a resource quota in the host namespace where the virtual cluster is running, because all the pods that get created, no matter how many namespaces the user has internally inside their vCluster, right? All the pods end up in a single namespace, and you can restrict them with a single resource quota pretty much. And yes, the nodes are shared, right? So this, like we said earlier, right? They get scheduled like regular other pods. You can have admission control on these pods, right? So if you're creating a privileged pod inside your vCluster, for example, right? That's setting some security context parameters. You have two options there. You can either tell the vCluster syncer to strip it away, right? For certain things, we do it by default. You can also disable these things, right? Because we already kind of know they're bad, right?
Yeah.
And if you want to do some stuff on top, you can just have regular mutating and validating admission control inside that namespace.
Nice.
Both of these options still exist.
Yeah. So as I understand it, you're saying one of the things you're saying too is the prime clusters can have many V clusters per namespace. It's like a one-to-many, but the opposite isn't true, right? I can't have one V cluster across many prime namespaces. If I'm using this term, I'm making up, and I'm gonna make it stick.
Is this some bid to get Twitch Prime memberships or something?
Well, maybe I'm a Transformers fan, and I like Optimus Prime and Rodimus Prime and all the other primes. You never know. We'll leave that up to the audience. Let them figure out why I came up with that. So, all right, I'm tracking all these questions. Let's see. I think, Biker, we answered the question of vClusters inside cloud systems. It sounds like yes, you can run it in AKS, EKS, all the clusters.
Private clouds, air-gapped environments. That was actually funny, like as a company, like our commercial product, when we first shipped it, we thought like, we're not going to need like air gap and stuff like that. That's way down the road. Like our very first customer was like, no, half of our environment is air gapped, all like no internet connections, make that work for us. So since then, everything we ship works in air gapped environments as well.
Yeah. By the way, I have to interrupt. Martin, thank you so much for your super chat. You get the reggae horn. That's like next level stuff right there. So thank you so much for the super chat. But Biker's got another question. I think we kind of touched on this, but can virtual nodes have different characteristics, say 16 CPUs when there's actually only 8 CPUs in a node?
Yeah, there's a lot of freedom in what you can fake there. But the question is, do you actually want to do that? Because you're kind of promising the vCluster a lot more resources that it can actually use. That may have like, adverse side effects, I would call it,
right,
for the user inside of the vCluster. But yeah, I guess technically that's possible. Actually, if you can write a plugin for vCluster, and that completely lets you customize all that syncer logic. So right now, when you're using vCluster out of the box, that syncer component comes with like pre-equipped sane standards that we put in place, right, for all these things. And we expose certain flags where you can, tweak the behavior a little bit. But if you want full customization, for example, you say, hey, I also even want that one CRD to be synced, right? There may be cases for that as well. Let's think of things like you have a multi-tenant Istio already running in your underlying cluster, and some networking configuration needs to be synced for that to work, right? You can add a plugin for that and hook it into these vClusters. Same counts for nodes. If you want to do something custom there, you can write a vCluster plugin, completely customize everything.
Nice. I think we've kind of answered this one. Where do you store persistent data? Config map secrets from etcd. So, I mean, I saw in your diagram there, you're creating an internal etcd or SQLite or whatever you're doing there. So that's probably just using a PVC from the parent or the prime cluster. Is that my assumption correct?
Yes, that's correct. Yes, that's a default data store. But you could literally also use like I don't know if AWS has a managed etcd service that you connect to, right? Like right. It's up to you where you want to connect it to.
Right. How do you dry run commands with server and client? Would that just be the same as a regular dry run kube control?
Pretty much, yeah.
Yeah. All right. Rapid fire. We're going pretty long, people, and we're going to try to get through these questions. If the pods are all in a non-virtual cluster, how well isolated are they from one another? I'm thinking of using use cases of pods handling sensitive data.
Yeah, I mean that's the regular Kubernetes multi-tenancy problem, right? Like in the end, you're still having pods sharing a cluster. So vCluster abstracts the control plane, right? So you're having a lot of the Kubernetes resources now really securely isolated because they only exist virtually in your own data store. Nobody else can touch your virtual cluster. You can't touch anybody else's virtual cluster. You can't touch the underlying EKS cluster. It's a lot more secure already. But your workloads, in the end, like if you launch a pod inside a vCluster, that pod gets spun up by the underlying EKS cluster, and now there's a network request to another namespace's pod, right? You're just using the IP to connect to it, right? If you don't have a network policy in place in your underlying cluster, that will be possible, right? Like
Right.
that is regular Kubernetes stuff that you need to put in place. So we kind of see vCluster as an additional security layer rather as the only security layer, right? So it enables more secure multi-tenancy, but you can't forget about all the basics. You're still going to need network policies, resource quotas, right? Everything we talked about, you're still going to have that on the underlying namespaces, admission control to restrict the actual workloads that your engineers are spinning up.
Right.
Yeah,
Sounds like...
I have a
go
friend.
ahead.
Oh, I was just going to say, I have a friend who's a really big Kubernetes security nerd, and he was poking around at vCluster, and that was like the first thing he said, right? Is that, folks are definitely going to want to use network policies and admission control on the underlying cluster, just like they would with anything else. The bottom line is when it comes to things like, compliance, every use case is different. Everybody's situation is different. It might turn out that this isn't hard enough multi-tenancy, for like some use cases that people have, and maybe they'll have to have a dedicated cluster for that specific app, so it's not necessarily going to solve every problem,
Right. You're still vulnerable to kernel attacks, like we've had a couple recently, sadly, that can escape a pod in a container, and that's not going. None of these abstractions are really going to help you with that if you're still running multi-tenancy on the same physical node, right? Like there are limits to what. Again, this isn't real virtualization. We're not doing hardware level virtualization here. All right, a couple more rapid fire questions, and we're going to have to wrap it up, people. I love all the questions. We're going to see if I can get to some of the ones that haven't been touched. Got that one. How about security? I think we kind of answered this one. Can you access data in that Nginx pod from the real Kubernetes? Because that's a real persistent volume. Well, if it had one, I don't think we'd give that example, but it's still a pod on the real cluster. It's still going to be a volume on the real cluster, right?
Yes, your IT will still have access. If they're cluster admin and EKS, they'll still be able to access your pod logs, your volumes in there, right? Everything that actually runs your workloads. One thing in terms of security, kind of as a spoiler again, I'm spoiling a lot on this show actually. We have a feature coming up called isolated mode. Because we've seen that a lot, people still have to put network policies in place, resource quotas, all these things, right? And, there are obviously a lot of cases where you want to tweak that, but in the easiest case, you just want kind of like a base level of security set up. So what we actually will be shipping with version 0.7 of vCluster, which is going to come up in I think 10 days from now is when it's scheduled, is the isolated mode. So our Helm chart will include like basic network policies, resource quotas, etc. So when you run that Helm install command or vCluster create, it doesn't just create a stateful set and a service. It also creates a network policy, resource quotas, limit ranges, everything that you kind of need to isolate that virtual cluster a little bit more than you would do, by just creating a stateful set and letting the user connect to the API server.
I can see multiple applications of that, but it's like the number one reason so that in case you want to run multiple virtual clusters in a single namespace, that at least you're creating some sort of isolation. Is that kind of the primary?
Or even in different namespaces, right? You want to prevent that the pods that your users are spinning up inside the vCluster, they can't communicate with other virtual clusters pods, right? Whether that's in the same namespace or in a different namespace. You just want to isolate each virtual cluster a little bit more than it is out of the box. So we're adding kind of these underlying constructs to Kubernetes as well.
So you're saying basically that if the IT prime cluster doesn't have any namespace policies on it, or network policies rather, then you could still do that in vCluster to actually isolate your stuff from other stuff that you don't run. Maybe if you're only given that namespace, you could actually control this yourself. That's pretty interesting.
Yeah, I mean, if your IT already
and you
has
can-
like namespace-based multi-tenancy in place, right, and they have rules and ways to automate that and set that up, that's fine. You won't need isolated mode. But we said it earlier, right? If your IT says like, oh, we can't do that because it's insecure, right? There's a way for them to kickstart things, essentially. That's the idea
Right.
behind it.
Yeah, and you can turn that on or off, the isolated mode, so you don't have to use it if you don't want to.
Yeah, that's pretty neat. And you're saying it's just an option at the command line, so that's basically like sort of some default policy. That's pretty nice. Martin's asking another question: syncing real nodes, AKS node pools with taints by node labels. On what level do the tolerations get forced into the workload? We're down the rabbit hole, people.
Martin,
on what level do the tolerations get
it's good
forced?
that he made that donation because, we should be billing him for this one. No, I'm just kidding. It's a great question.
It is a good one. I wasn't going to
Yeah,
ask anything
so-
about taints, but yeah, let's do it.
Yeah, that would actually be enforced by the underlying cluster. You would see, I think, you would see the information about that being the client in the events of the virtual cluster. So there's some visibility into, hey, why didn't this pod actually get scheduled? You're going to see that information. You're also going to see it in the, when you're describing the pod, you're going to see those events listed in your virtual cluster as well. So the user will see what is wrong, right? But we're also going to rewrite the names there if you're using fake nodes. Right? If you're using the real names, it's fine. If you're using the fake nodes, we're also rewriting them there.
Right. So in other words, I guess the syncer is syncing taint information as well, so that you can see that inside the vCluster.
It depends on what you configure, right? So you could essentially adding that information in your, so like, do you see it on the node? Depends, right? I think our default is yes. No, I think we wouldn't show it to you because our default only shows nodes that actually have pods on them. If there's a taint on there and you can't even schedule on there, you're not even going to see that node.
Right.
But you can enable to see all nodes, and you can disable fake nodes. Then you would make that information transparent, or you would have a syncer plugin to kind of customize what people should see, right? It's up to you, the level of visibility that you want to add there. But for, the underlying, in the underlying cluster, that's actually where it would be enforced. The vCluster would not do any kind of logic on that end. It would literally just copy the pods back. You could tell it, please add it, a certain node selector and stuff like that, right? And that would be considered in your underlying cluster as well, including your taint, right? But the virtual cluster itself doesn't do any scheduling logic.
Right. And that's actually like a good tidbit, like for the show notes, is it's passing scheduling on to something else. So there's not scheduling within scheduling within scheduling, which that in and of itself is hard to imagine the levels of complexity that you would get to pretty quickly. If I've got taints inside taints inside taints, I just can't. I don't know that I could ever. I'm used to proxies all the way down. I'm not sure about everything else. So
there's a meme in this somewhere. I know.
Absolutely. I think Kubernetes in and of itself is kind of like easy meme targets. So this one I was wondering myself, and we may have touched on it. I'm going to give it two more questions, and then we're going to wrap it up. But this one's about, like, when you're thinking about the potential for things inside your vCluster needing to talk to other things outside the vCluster, what is the path for how and thank you so much, person on the internet, for saying prime cluster. Now it's a thing. Someone said it. So the vCluster pods, how do they communicate with, let's say, services on the prime cluster pods?
Yeah, that's an awesome question. So essentially, what we do is, besides syncing the pods, so you saw that we spin up core DNS inside the virtual cluster. So the virtual cluster has its own internal DNS. So cluster internal DNS works just as expected inside the vCluster. But obviously, because the virtual cluster is kind of sharing an underlying cluster, there is a curiosity around, hey, can't we share certain things and others we keep separate, right? A good example is actually the ingress controller, for example. you don't really want every one of your users to spin up their own Nginx, and that would need a load balancer attached from AWS, right? There's a lot
Right.
of like complexity involved there, right? So IT just rather wants to say, hey, we create the load balancer, we maintain Nginx, we maintain Cert Manager, right? And the user inside their virtual clusters is supposed to just create ingresses. In that case, what we would do, and that's actually default enabled in vCluster because it's a very, very common case. But again, you can also disable that to have stricter isolation if you really want everybody to run their own ingress controller. If you want it to be shared, what we do is we synchronize the ingresses and we synchronize the services as well, and we just rewire them. So that means we essentially rewrite selectors, like the label selectors and things like that. We rewrite the service name when we sync it. So we rewrite the service selector inside the ingress after we sync it, right? Like everything gets renamed and there's no collisions and stuff like that. But in the end, we wire it up so it works. It's a most common case. Yeah. And then regular pod-to-pod IP-based communication works out of the box because your pods just run inside the EKS cluster. Everything is the regular networking inside your cluster.
So my guess is the fully qualified domain names are getting pretty long at this point. Is it like subdomains when you're inside a vCluster? If you're trying to talk to like the prime cluster, you're essentially kind of like you do the names of the pods themselves. You're sort of nesting the DNS scope.
Yeah. So what you would do for, let's say you want to share. So one way is kind of like what I said, the ingress controller, like traffic comes into your pod, right? But then there's the other way, your pod wants to connect to a shared service. So let's say you have IT says like, hey, Kafka is really hard to maintain and very costly, so we're going to run that for you, right? And now your pods need to connect to a service of that Kafka cluster, right? And then the question is, how do you do that? The way how we suggest you do it is you create a Kafka service inside the virtual cluster. You just create a service and you tell vCluster, please sync that service, right? By default, we have service sync enabled. So we would already sync that. And the only thing you need to tell the vCluster is, please don't adjust the selectors, right? Don't do that magic with translating selectors because it would kind of mess it up. Please leave it like it is and point it at the real thing. And then it works out of the box. Your cluster internal DNS is going to now see that service. Your name is actually very short, right? When you're actually coding with it and writing your pod, it would be very, very short. Because for you, it's just a regular service inside your vCluster, and it's just up to configuring vCluster to not mess around with that particular shared service.
Right. I like it. That's because, names in Kubernetes are long enough if you're trying to use cross namespace DNS names. Because I'm thinking of like the monitoring servers, the logging servers. How do I connect to all those? And that's kind of what you're going to have to get into there. Thank you so much for that question. All right, I think we're on the last one. How is pods we kind of answered this already, I think a little bit. How is pods in vCluster isolated from scheduler from the primary cluster, and how primary scheduler relates to vCluster? So Alexander, if you haven't watched the whole show, we covered a lot of this stuff, but what could you give me like the short answer for Alexander?
Yeah, I guess the short answer is we don't have a scheduler inside the vCluster. We copy pods down to the real cluster, and then the real scheduler actually schedules that pod, right?
Yeah.
So that's kind of how it relates. And then we get the status information from that pod and sync it up to the, virtual pod inside the vCluster. That's kind of how it works.
Yeah, that sounds like the real work and the magic of this solution is the sync there.
Absolutely. Mm-hmm. Yeah, so there's that, that internal data store, inside the vCluster, and that state is just getting synced back and forth to the host cluster.
Nice. All right. Well, thank you so much for everyone for all those questions. You've been amazing today. Let's just recap. We can get more information on vCluster at vcluster.com, right?
Exactly. That's the website. We have a Slack channel as well. Feel free to join that if you have any
detailed
questions. I know that those questions were pretty deep. We do charge by the hour in the Slack channel. No, I was just kidding.
No.
The software's free, but we're not. Very nice. And it's stored on GitHub, so people can go take a look at the open source project and get involved, look at, create some more feature requests, because clearly, for a project only would you say less than a year old, it sounds like you've covered a lot of the edge cases, or at least what I would maybe classify some of the edge cases. So it sounds like a pretty great project. I'm going to have to find a reason to use it somewhere.
The nice thing too is with the plugin SDK that kind of lets you deal with the rest of them, right? So the ones that we haven't gotten to, the edge cases, a lot of those you can address yourself by writing plugins.
Yeah. Well, and thank you so much to both of you for being on the show. For those that haven't checked out Loft Labs, go check them out, as well as vCenter. And
you just said vCenter.
I said vCenter.
Finally.
We're going to edit that out in post. That's what I tell my team. Anytime, look for the word vCenter. By the way, I have my podcast software has a robot voice of me. So I had to read it like 30 minutes of a book, and then it now can replace my voice with my voice. So I can take, and so for the podcast, you'll never hear vCenter. You'll only hear vCluster but it'll be in my robot voice, which I even have a hard time telling the difference. So nobody will know. It's our secret. That and the rest of the internet, it's only live forever permanently on YouTube. So thank you all for showing up. Thanks for all the great questions. We will be back here again in future Thursdays. By the way, for Lukas and Rich, you can see their Twitter handles below, so go bug them on Twitter. I'm sure they're glad to answer all your questions for gratis. But we've got coming up, we've got the High Fiver chat I mentioned in a couple of weeks, so check out patreon.com/Bret Fisher. We'll have that chat here on the 16th of March. And then we've got a podcast coming out tomorrow about Portainer, which is a web-based. If you didn't see that show, it's I think one of the best web-based controllers now for Kubernetes. It used to be for Docker and Swarm, but now it's Docker, Swarm, Kubernetes, all the things, all in one web app. That podcast is coming out tomorrow. And then we've got Pulumi and HashiCorp coming up, and Shippa. We got a whole bunch of companies showing off their products here in the next couple of weeks. So come back and join us, won't you? Thanks again, guys. It's great to see you.
Thank you.
Thank you for inviting us.
Yeah. And we will see each other on the internet. Ciao, everybody.
Absolutely.